Okay, hi everyone, welcome to back to this video series on data centers. Wildcard masking. Wildcards are used to access lists to specify an individual host, a network, or a certain range of network or networks. To understand a wildcard, you need to know that a block size is used to specify a range of addresses. Some of the different block sizes available are 64, 32, 16, 8, and 4. When specifying a range of addresses, you choose the next largest block size up that's required to meet your needs. This means that if you need to specify 34 networks, you would specify a block size of 64. For 18 hosts, you need a block size of 32, and for 2 networks, you would go with a block size of 4. Wildcards are used with the host of network addresses to tell a router a range of available addresses to filter and to specify a host. And the address would look like this: 172.16.30.5, 0.0.0.0. The 4 zeros represent each octet of the address. Whenever a 0 is present, it means that specific octet in the address must match the corresponding reference octet exactly. Another command you can use to match the exact IP address is this: host 172.16.30.5. There's no difference between using the host command and the 0.0.0.0 wildcard option to state that an octet can be any value. 255 is used as an example. Here's how a 20/24 subnet is specified with a wildcard mask: 172.16.30.0.0.0.0.255. This tells the router to match up the first 3 octets exactly, but the 4th octet can be any value. That was pretty easy, but let's say you want to specify only a small range of subnets. This is where block sizes come in. You have to specify the range of values to be comparable with your chosen block size. You can't choose to specify 20 networks because there is no size 20 block size. So your choices are limited to either 16 or 32, and as I said, you need to go with the next block size up, not down, meaning you can go with 32. Let's say that you want a block size to part of the network that is in a range from 172.16.8.0 through 172.16.15.0. That's a block size of 8. So your network number will be 172.16.8.0, and the wildcard would be 0.0.7.255. Well, what is that? The 7.255 is what the router uses to determine the block size. The network and wildcard tell the router to start at 172.16.8.0 and go up to a block size of 8 addresses to network 172.16.15.0. Seriously, it really is easier than it looks. I could certainly go through the binary math for you, but no one needs that. Actually, all you have to do is remember that the wildcard is always one number less than the block size. So in my example, the wildcard would be 7, since my block size is 8. If you use a block size of 16, and the wildcard will be 15. But just to be sure you've got this, I'll guide you through a few more examples. The following example tells the router to match the first 3 octets exactly, but that the 4th octet can be anything: corp config access list 10 deny 172.16.10.0 0.0.0.255. The next example tells the router to match the first 2 octets, but the last 2 octets can be any value: corp config access list 10 deny 172.16.000.0.255.255. Hopefully this is getting crystal clear. Try to figure out what the next line is specifying. Corp config access list 10 deny 172.16.16.00.0.3.255. This configuration tells the router to start at network 172.16.16.0 and use a block size of 14, making your range 172.16.16.0 through 172.16.19.255. Oh, and to give you a heads up, this particular example just happens to be favorite Cisco objective. Okay, so keep practicing and take a shot at this one. Corp config access list 10 deny 172.16.16.00.0.7.255. This example describes an access list starting at 172.16.16.0 and going up to a block size of 8 to 172.16.23.255. And you can determine the range for this one. Corp access list 10 deny 172.16.30.00.15.255. This example starts at network 172.16.32.0 and goes up to a block size of 16 to 172.16.47.255. Okay, you're almost done. Just a couple more examples before moving on to extended ACLs. Take a look at this configuration and determine the range. Corp config access list 10 deny 172.16.64.0.0.63.255. This example starts at network 172.16.64.0 and goes up to a block size of 64 to 172.16.127.255. One last example, corp access list 10 deny 192.168.160. 192.168.160.0.0.31.255. If you answered that it starts at network .192.168.160.0 and goes to a block and goes up to a block size of 32 to 192.168.191.255, you've nailed this. If not, just run through the examples another time and I'm sure you'll get it down. Here are two more things to keep in mind when working with block sizes and wildcards. Each block size must start at 0 or a multiple of the block size. For example, you can't say that you want a block size of 8 and then start at 12. You must use 0, 7, 8, 15, 16, 23, and so on. For a block size of 32, the ranges are 0, 31, 32, 63, 64, 95, and so on. The command Annie is the same thing in writing out the wildcard 0.0.0.0.255.255.255.255 extended access lists. Standard access lists have simply become too limiting for use in our enterprise networks today because you can't allow users to get to one network service but not another. It's all or nothing with standard lists. They won't allow you key options like making decisions based on both source and destination addresses, protocols, and port numbers, and the ability to restrict or allow based only on the source address just doesn't cut it anymore. On the other hand, an extended access list will really brighten your day. These beauties will allow you to specify the source and destination address, as well as a protocol and port number, which will even identify the upper layer protocols or application by using Extended access lists. You get lots of levels of control, and you can effectively allow users access to a physical LAN, yet still completely prevent them from accessing specific hosts, even specific services on specific hosts. To let you begin at the basics while learning ACL configuration, here's an example of an extended IP access list on iOS. 199 access standard list, 100 199 IP extended access list, 1100 1199 extended 48-bit MAC address access list, 1300 1999 IP standard access list, expanded range 200 299 protocol type code access list, 2000 2,699 IP extended access list, expanded range 700 799 48-bit MAC address access list, complied enabled IP access list compilation, dynamic extend the dynamic ACL absolute timer, rate limit, simple rate limit, specific access list. The first command shows the access list numbers available. I'll use the extended access list range from 100 to 199, but still make sure to note that the range 2000 2699 is also available for extended IP access lists. At this point, I need to decide what type of list entry to make. For this example, I'll choose a deny list entry. Corp config access list 110 question mark deny, specify packets to reject, dynamic, specify a dynamic list of permits or denies, permit, specify packets to forward, remark access list entry command. Once I've chosen the ACL type, I need to select a protocol field entry. 0255 an IP protocol number, AHP authentication header protocol, EIGRP, Cisco's EIGRP routing protocol, ESP encapsulation security payload, GRE, Cisco's GRE tunneling, ICMP internet control message protocol, IGMP internet gateway message protocol, IP any internet protocol, IP INIP IP and IP tunneling, NOS, KA9Q, NOS compatible IP over IP tunneling, OSPF, open shortest path first, routing protocol, PCP, payload compression, protocol, PIM, protocol independent multicast, TCP, transmission control protocol, UDP, user grant data protocol. Here you'll choose to filter an application layer that uses TCP by selecting TCP as the protocol. You'll specify the specific TCP port later. Next, you'll be prompted for the source IP address of the host or network. Choose the ANY command to allow any source address. Corp config access list 110 deny TCP ABCD source address. ANY source address host, a single source host. After you've selected the source address, you then get to select the destination address. Corp config access list 110 deny TCP any ABCD destination address, any destination host, EQ, match only packets on a given port number, GT, match only packets with a greater port number host, a single destination host, LT, match only packets with a lower port number, NEQ, match only packets not on a given port number range, match only packets in the range of port numbers. In the following example, any source IP address that is a destination IP address of 172.16.30.2 has been denied. Corp config access list 110 deny TCP Any host 172.16.30.2 question mark ACK match on the ACK bit DSCP match packets with given DSCP value EQ match only packets on a given port number established match established connections fin match on the fin bit fragments check non-initial fragments GT match only packets with a greater port number log matches against this entry log input log matches against this entry including input interface LT match only packets with a lower port number NEQ match only packets not on a given port number precedence match packets with given precedence value PSH match on the PSH bit range match only packets in the range of port numbers RST match on the RST bit SIN match on the SIN bit time range specify a time range TOS match packets with a given TOS value URG match on the URG bit CR. Once you have the destination host address in place, just specify the type of service you want to deny using the equal to command, which you would just type in as EQ. The following help screen shows you the available options. You can choose a port number or use the application name corp config access list 110 deny TCP any host 172.16.30.2 EQ 065535 port number BGP border gateway protocol 179 jargon character generator 19 CMD remote commands or CMD 514 daytime 13 discard 9 domain name service 53 DRIP dynamic routing information protocol 3949 echo echo 7 exec RSH 512 finger 79 FTP file transfer protocol 21 FTP data connections 20 gopher 70 hostname NIC hostname server 101 ident protocol 113 IRC internet relay chat 194 KLOGIN Kerberos login 543 K-shell Kerberos shell 544 login or login 513 LPD printer service 515 NNTP network news transport protocol 119 PIM also RP PIM auto RP496 POP2 post office protocol version v2 109 POP3 post office protocol v3 110 SMTP simple mail transfer protocol 25 SUN RPC SUN remote procedure call 111 syslog 514 telnet 23 time 37 UUCP Unix to Unix copy program 540 who is nickname 43 www.worldwideweb http 80. Okay, now let's block telnet port 23 to host 172.16.30.2 only if the users want to use FTP. Fine, that's allowed. The log command is used to log messages every time the access list entry is hit. Be careful when you use this because it could overload your console with an enormous amount of messages. Here's our config result. Corp config access list 110 deny TCP any host 172.16.30.2 EQ23 log. You need to keep in mind that the next line is an implicit deny IP any by default. If you apply this access list to an interface, you might as well just shut it down since there's an implicit deny all at the end of every service list by default. Instead, you've got to follow up the access list with the following command: corp config access list 110 permit IP any. Remember the 0.0.0.0 255.255.255.255 is the same command as any. So this command could also look like corp config access list 110 permit IP 0.0.0.0 255.255.255.255 0.0.0.0 255.255.255.255. But if we left it like this, the command would be replaced with any when you've looked at the running config. So we'll use the any command because less typing is always nice. Okay, once we've created our ACL, we need to apply it to an interface using the command as the IP standard is corp config IP access group 110in. Doing this is your option. Corp config IP access group 110 out. Now that you've run through the basics, it's time to advance with some examples of how to use an extended access list. Extended access list example. Referring to figure 13.1 below, let's deny access to a host at 172.16.50.5 on the finance department LAN for both Telnet and FTP services. Allow other services on this and allow other hosts are acceptable for the sales and marketing departments to access. The following access list should be created: lab a hash config 1, lab a config access list 110 deny TCP any host 172.16.50.5 EQ21, lab a config access list 110 deny TCP any host 172.16.50.5 EQ23, lab a config access list 110 permit IP any. The access list 110 tells the router we are creating an extended IP access list on an iOS device. The TCP is the protocol field in the network layer header. If the list doesn't say TCP here, we can't filter by TCP port numbers 21 and 23, which is what we need to do. Remember, FTP and Telnet both use TCP for connection-oriented services. The any command is the source, which means any source IP address, and the host is the destination IP address. This ACL specifically states that all IP traffic except FTP and Telnet is permitted to host 172.16.50.5 from any source. After we've created the list, we need to apply it to Ethernet 3.2 interface outbound because we want to block all traffic from getting to host 172.16.50.5 and performing FTP and Telnet. But remember, if this list was created to block access only from the sales LAN to host 172.16.50.5, then we'd want to either place it closer to the source or put it on Ethernet 3.1. In this situation, it is best to apply the list to inbound traffic in order to prevent extra overhead on the network before packets are dropped. This is a great example of why it's important to examine each situation individually and carefully before creating and applying ACLs. Let's go ahead and apply our list to interface E3.1 and block all outside FTP and Telnet access to 172.16.50.5. lab a config int e3/1 lab a config IP access group 110 out. Now it's time to move on and create extended ACLs using the using names on NXOS. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.